Welcome to the Stormsurf video surf forecast for the week starting Sunday, June 24th. Looking at significant wave heights for the South Pacific Ocean, we see a rather calm pattern. Yes, there was a gale that passed just south through the Tasman Sea, produced 28-foot seas, and it's kind of regenerated at the moment south of New Zealand, but is to quickly fade. And another gale is starting to wind up, but outside the California swell window, targeting only Chile with 38-foot seas or so. But in the core, right here, of the South Pacific Ocean, in the Hawaii and California swell window, really nothing is going on. Let's get into the details looking forward. As usual, we'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and they do form, help direct their track. We're looking for a trough, that is a push in the jet to the north. That helps create a clockwise flow aloft right here, sort of like an eddy. And that clockwise flow aloft is the hallmark of low pressure in the southern hemisphere. Remember, counterclockwise in the northern hemisphere. But in the southern hemisphere, that's the hallmark of low pressure. And that also manifests itself down on the ocean surface a bit. And of course, low pressure generates winds. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, creates surf. So we have a little bit of a trough. One would think that maybe that would help support low pressure there. Let's sort of move into the future. And that trough continues off to the east into Monday morning, then kind of pinches off. Not a whole lot of winds pushing up the west quadrant of it, and that's really what you want. So it looks like whatever support for gale development there would fade. And notice here, just off to the east, big ridge pushing south. The ice line's down around 65, and for the most part, the ridge would promote high pressure aloft, counterclockwise flow, and that of course does not support winds or swell development. And that pretty much is the case other than this trough trying to develop outside the Southern California swell window. Anyway, so we roll into Tuesday, Wednesday. Again, no real trough. I mean, sort of a weak trough, but no real winds associated with it. Till we get into Wednesday, a little bit of fetch, or not winds, actually upper level winds, start building 120 knots pushing to the north. So a new trough starts building in the same area, maybe offering some hope, actually looking pretty good as we get into Thursday. So when we get down to the surface level charts, we'll see whether low pressure develops in that area. Anyway, that pushes off to the east into Friday and then starts falling apart, kind of gets cut off here. See ridging behind that, pushing well down over the Ross Ice Shelf, also ridging in the far East Pacific, Southeast Pacific, offering no support there. We'll roll this out, and you see that ridging pattern kind of continues, until we get the whole way out to Monday or Sunday night, a week from now. So, really, maybe one trough under New Zealand. That's the only thing offering some hope. Let's go take a look at the surface level pressure charts. Here we are, surface level pressure, surface level winds. Remember, there's a trough right here under New Zealand. Yeah, 35-knot winds to the north. That's not enough to get a swell with enough energy to it to make it up to Hawaii or California without decaying into nothingness. Stronger fetch outside the California swell window, so Southern California, easternmost extent is about 117, 118 west, something like that. So this is outside of that area and aimed off to the northeast, targeting mainly Peru and Chile. 50-knot winds, though, not bad. But that sort of dissipates. Another little fetch tries to fire up as we get into Monday, 35-knot winds, and this fetch over here in New Zealand, same deal, not doing a whole lot, not strong enough winds. And then notice high pressure, ridge building, south or north winds pushing south, 35 knots as we get into Tuesday. No hope there. A bit of a fetch tries to organize here off of New Zealand on Wednesday, Thursday, but again, only 35-knot winds. Just, we need to see 40 at least, preferably 45, and really, preferably 50-knot winds. Don't think that's going to happen. We see just kind of this muddled pattern, a little low, tries to organize there. Tiny area, 40-knot winds. Sunday, we're almost a week out, and then quickly decaying to 35 knots. Again, just nothing really happening. Very calm pattern. All right, so let's go take a look at the wave model charts, see what's going to happen. But before we do that, we're going back in time just a little bit to Wednesday, June 20th. The reason? Small gale developed southeast New Zealand, 33-foot seas, and that moved east-northeast, was that up to almost 34-foot seas on the 18Z on Wednesday, then fading from 30 feet and kind of decaying out from there. The point being, yes, tiny little swell likely generated, pushing towards Hawaii and the U.S. West Coast for maybe sometime next weekend. We're not talking anything significant, but that is literally the only thing that is going on. We'll just roll this out and you can see no seas in excess of 30 feet. Here's that system that moved through the Tasman Sea on Saturday. 28-foot seas, 27-foot seas, 28-foot seas, and then we're basically where we are today, and there's the new system outside of the California swell window. So Fiji, yeah, we'll get some swell, maybe tiny background swell filtered by Fiji for Hawaii, but basically not a whole lot is going on other than that one small fetch southeast of New Zealand on Wednesday. So here we are, current picture. We'll just scan what's going on. We're looking for 30-foot seas in the California swell window, which is pretty much running on a line from there down to about a line up here. So between this line and over down in this area. And we'll see if we get it. Looking. Okay, there's our one little fetch. What's that? 20, 22, 24, 25-foot seas. That'll be pretty much decayed to, 13 or 14 seconds period. It could reach Hawaii, maybe California, but probably nothing of any real interest to result. And here we are, we're out into next weekend already, and again, nothing in the swell window. Keep going, hoping, don't see it. So right now, kind of a swell drought. It looks like pulse coming for the coming weekend. Then after that, a week of nothingness, and the jet stream not looking particularly strong. The other point being, if there's nothing in the Pacific, normally there is something somewhere. And if you have a moment, go look at the South Atlantic swell significant wave height charts, and you'll see that's where the focus of energy is right now. And that's mainly because the active phase of the MJO is over in that area, not in the Pacific. And with that, that segues us into the long-term outlook. But just one quick detour before we go there, because there is wind swell for the local California northeast Pacific basin. So here we'll roll this out. You can see high pressure here, 1032 millibars. What is that, about between 900 and 1200 miles northeast of Hawaii, generating a clockwise fetch. 15-knot winds extending from off California over the Hawaiian Islands. That's good for wind swell there. So you just sort of keep your eyes on this fetch relative to Hawaii. Also, this high pressure going to start working its way towards California. Also, you notice a little bit of low pressure. It actually generated on Saturday, I believe it was, some 30-knot winds and 16-foot seas. So that'll create some wind swell. But whatever wind swell comes from the northern Gulf will be buried in local wind swell off of California. So here we are into Monday. High pressure, in control, north winds, 20, 25 knots. This will make for very small wind swell relative to California. Eddy flow still along the coast. That is sort of like a low pressure here, and it'll actually push south winds up here along the coast. So you get the northwest wind swell, but not the northwest winds. A south fetch instead. Hawaii, wind swell, still looking to be in control. Then we get into Tuesday. The gradient gets a little bit better defined. 25-knot north winds over northern California. Lighter flow down south, but still starting to build. Wind swell for sure for Hawaii. Look at that. You're talking a couple thousand miles, or 2,000 miles of east-northeast fetch. Nothing great, though. It's only 15-knot winds. Maybe a 7 or 8 second period wind swell. Local winds, again, building Wednesday, 25 knots over northern California. More wind swell. Basically, the same thing just goes on and on. Gradient falls south on Thursday relative to California. Also notice the fetch breaks up a little bit relative to Hawaii as you get into Friday. And then on Saturday or late Friday, notice the high pressure getting very close to the coast. Heat low inland creates a difference in pressure. That's what's called a gradient as the isobars get very tight right in this area, and therefore the wind starts building. They're up to 35-knot winds. That's good for local wind swell for California, but the fetch relative to Hawaii fades out, and that builds a bit more into Saturday. And then as you get into almost Sunday, look, it's a broad area, 35-knot north winds. There's that low pressure we talked about, probably an eddy flow along the coast. So bigger wind swell with relatively decent wind conditions look possible as we get into Sunday, and some fetch aimed at Hawaii, maybe still more wind swell. Then the gradient starts falling apart as you get in later into Sunday and moving north, and that's probably going to be the end of it for a little bit. And now we move to the long-term outlook. What's going on with the Madden-Julian Oscillation, and what's going on with La Nina, El Nino, commonly known as the El Nino Southern Oscillation. As usual, we like to monitor the status of the Madden-Julian Oscillation in the Pacific, because when in the active state, it tends to help fuel energy transfer to the jet stream, and that in turn helps fuel storm development, more notably in the northern hemisphere in winter months, but also it gives a good push to the jet stream in the southern hemisphere in southern months. So we look at winds. This from the TAO buoy array. Here's the equator, East Pacific here, West Pacific here. There's New Guinea. Actual winds, these are the series of buoys strung across the equator used for monitoring El Nino, La Nina, but they also give us some other clues as what's going on in the atmosphere. We see east winds. We're just looking at the arrows. Pretty strong over the eastern half of the Pacific, but weakening and almost dead as we get to the West Pacific. But what's that mean in context? Well, anomalies, differences from normal for this time of year. So, while the winds typically blow pretty hard over the east, they're called trades, over the East Pacific this time of year, and looking at the size of the arrows and the direction here, it's pretty much normal, neutral. No arrows, really. And then as we get here towards the, not quite to the date line, we see actually westerly anomalies developing, meaning these east winds are weaker than normally expected, and that actually gives you what in effect is a westerly component, and that continues into the Kelvin wave generation area. What's the Kelvin wave generation area? It's the area from 170 west, 5 degrees north and south of the equator, out over to about 135 east. And this area, if you have warm water in the air and enough westerly anomalies, they'll actually help create a Kelvin wave. Take warm water from this area, form it into a bubble, push it under the equator, and it'll traverse the whole width of the Pacific, eventually erupting off of the Galapagos Islands or in that area, Ecuador. And that sometimes is how you start El Nino. Take a quick look at wind anomalies. So here's South America. This is over the past 5 days. There's New Guinea. Kelvin wave generation area would be 5 degrees north and south of the equator from 170 west, so right in this area. So you see a sort of westerly anomalies here over the date line and well east of the date line, but not so much in the Kelvin wave generation area. And that we're just going day by day. You just sort of scan down here, look in this area. See a good westerly anomaly pattern, in the date line region, but not really well formed in the Kelvin wave generation area. And then here's zonal wind anomalies. So we're looking to the future, but actually this chart is the whole planet on one chart. The date line is right down the middle of the chart. Our Kelvin wave generation area, basically between these two tick marks, and you just sort of look down where you see blue, those are easterly anomalies, so that would mean the inactive phase of the MJO. If you see yellows over a sustained duration, that would be the active phase of the MJO. We don't see that, but we do see this sort of persistent westerly anomaly pattern, not really in the Kelvin wave generation area, because that would be more like over here, but on the date line and east of the date line. Not good for generating a Kelvin wave, but maybe good for at least preventing some upwelling over the Nino 3.4 region where they use for monitoring El Nino. And as you see now, here we go, starting June 19th, we started seeing easterly anomalies building, and that's forecast to get stronger in the heart of the Kelvin wave generation area, and then start sliding off to the east about a week from now. But this definitely smells like the inactive phase of the MJO. Then looking at outgoing long-wave radiation charts, basically another way to sort of get a sense of, what the MJO is doing. Yellows suggest positive sea surface outgoing long-wave radiation, meaning more sunlight reflectivity off the ocean surface, meaning high-pressure, cloud-free skies, meaning the inactive phase of the MJO. We see the blues sort of here in Africa and over Indian Ocean, maybe suggesting, well, maybe the active phase is over here, basically on the other side of the planet relative to the Pacific Ocean. But the statistic model suggests 2 weeks from now, we're supposed to be down to a dead neutral MJO pattern. At least the inactive phase would be gone from the Pacific Ocean. The GEFS model, basically the same thing. Active phase hanging here over the Africa area, and then slowly making its way towards the maritime continent while the inactive phase fades out, maybe heading east. Phase diagram charts up next. So basically assume you're looking down on the North Pole. The MJO goes from west to east, from the Indian Ocean over the maritime continent, across the West Pacific, over the date line, under the United States, across the Atlantic on the equator, across northern Africa, back to the Indian Ocean. Round she goes. The heavy dot is where the active phase is right now, so yeah, over Africa or somewhere in that area. That stands to reason. If you look again at the South Atlantic sea surface charts, a lot of activity in that area. That would suggest that that's probably where the active phase of the MJO is. Green line is the forecast. If you're inside this circle, it's considered to be extremely weak. So a very weak active phase per the ECMF model, migrating to Bali basically 2 weeks from now. The GEFS model, not even that optimistic, just weak and holding where it is. So a very non-committal, non-substantial MJO pattern appears to be in play. 40-day upper level model, okay? You see the yellows, that is areas not supportive of precipitation. There's New Guinea, the Philippines, South America. So one can assume the inactive phase of the MJO is in the West Pacific right now. It's just slowly, you can see it just work its way across and there, move right over in there. There's the Galapagos, Ecuador, move out of the Pacific, maybe about mid to mid-late July. And then the active phase of the MJO starts migrating its way into the Pacific, the 1st of July or so, and then does its multi-week, typically 4 to 6 weeks, to make the trip across the Pacific into the end of August, followed by another inactive phase after that. And 850 millibar wind anomalies. So this, you can see, we're going back in time. The dotted lines are the inactive phase of the MJO. Notice the blues, and right between these two spots is the Kelvin wave generation area. So as you can see, inactive phase, and then a pretty good active phase that occurred in late April. Another inactive phase in May. You kind of get the pattern here. Another active phase that kind of faded or is in the process of fading in June. And here we are right now. So there's this, the blues are easterly anomalies in the western Kelvin wave generation area. They're supposed to make some progress to the east, but here's the interesting part. Notice we have all these westerly anomalies, and also notice this. Oh, you can't see it. Here we go. The purple is low pass filter. We'll get more into that, but you want to see that. That is the area that's sort of biased towards low pressure, sort of favorable for the active phase of the MJO, and if it hangs on long enough, maybe indicative of El Nino. Notice it is setting up, building. We'll get more into that in a second. So these easterly anomalies and this inactive phase of the MJO, we're not too concerned about, because in 1, not even 2 weeks, it's supposed to be gone. And notice this, these westerly anomalies filling the Kelvin wave generation area, almost filling the entire Pacific Ocean after about a week and a half, 2 weeks from now. So this is going to be very interesting, and they're not even showing, at least in this image, any sign of the active phase of the MJO. It's just a bias towards westerly winds. We want to see that. And then yet another longer term outlook. So this one's past history is down here. The forecast goes this way. You can see Kelvin wave generation area basically from between these two tick marks here. So right in here, and there's that little bit of easterly anomalies in the far west Pacific. Here's your westerly anomalies on the date line. You can see as you get into July 10th, something like that, all of a sudden westerly anomalies start building and building and filling the Pacific and continue off into the foreseeable future. Let's overlay the MJO. So this is what's even more interesting. So this dotted line, this is your inactive phase of the MJO. But according to this model, we're supposed to have westerly anomalies building. How can that be? Well, we'll see in a second. But even beyond that, you get into last week in July, early August. The active phase of the MJO builds with more westerly anomalies, strong westerly anomalies, potential westerly wind bursts, potential another Kelvin wave being generated. And you all know from following us past couple of weeks, there's a good-sized Kelvin wave in the water right now and erupting. So potentially this could help set up yet another Kelvin wave. And then after that, we see another inactive phase of the MJO building, but westerly anomalies still in control. How can that be? There you go. The solid contour is the low-pass filter, the same low-pass we saw in the previous chart, and this is suggesting, solid contours suggest low pressure on-centered in the core of the Kelvin wave generation area, predisposing it to a sort of like long-running active phase of the MJO. So even though the MJO goes inactive, active, inactive, this sort of overrides it and makes the whole thing look like a continuous active phase of the MJO. That is exactly the scenario you need to set up El Nino. And notice, we had one contour back here in April, building to two contours, and then we're supposed to be going to three contours as we get into the July 10th time frame and holding into the fall. This is the preferred scenario for the development of El Nino. All right, so enough on the MJO for right now. We know basically that we're in the inactive phase, or it's coming, but a strong active phase is forecast to follow. What's going on in the ocean? Here we go. East Pacific here, West Pacific here, and we're looking at depth. These X's are anchor lines on the TAO buoy array, again on the equator. The same buoys used that we looked at for monitoring wind speed and direction, also mainly used for measuring temperature. The key here, 30-degree temperatures in the far West Pacific, but the 28 degree centigrade contour line has been steadily moving off to the east, meaning warm water is moving off to the east, and that being driven by trades weakening and or westerly anomalies building in the West Pacific. So I don't remember where the 28-degree line was last week when we did this, probably somewhere around 155 or 153 west. It's now moved to 150 west, so steady eastward progress continuing. The 24-degree isothermal line holding steady at about, well, it's 35 meters deep near Ecuador and far deeper as we go off to the east. But it's not the absolute temperatures, it's the differences from normal, again, anomalies. And we see warm water, sort of follow the contours here. You see warm water here, 1 degree above normal, then building to 2 degrees under the date line, and 3 degrees in the East Pacific. This is a Kelvin wave from a strong westerly wind burst that occurred in February. It's taken months to make it the whole way across the Pacific, and now it is pushing into Ecuador and erupting to the surface. So you can see the 1 degree isotherm line up here, and that is at about 135 west on into the coast of Ecuador. So when we go to the surface charts, we'll take a look and see if that actually manifests itself on the surface, but my guess is it will. So here's another version of that, different model used to drive it, but same basic raw data. There's our core Kelvin wave right there. Was that 1, 2, 3, 4, 5? 1, 2, 3, 4, 5. So maybe 4.5 degree anomalies in the core of the Kelvin wave at 120 west. That would be due south of California on the equator. All this moving off to the east, erupting on the surface between 150. That's almost like south of Hawaii, the whole way to 100 west or just east of the Galapagos. We'll see again whether that's actually the case. Yeah, again, we're also monitoring a bit of new warm water building in the far West Pacific. What it really needs is some westerly anomalies to push it off to the east and maybe get our next Kelvin wave going. Interesting. Upper ocean heat anomalies, so we're back in time here, August, September, October last year. That's the cool water. This is East Pacific here, West Pacific here. That's below normal waters. You can see that here. Basically, La Nina in the East Pacific, in the Kelvin, in the Nina 3.4 region. Small Kelvin wave, you can actually see it migrating from the West Pacific to the east right there. This was back in January, hardly noticeable. And then the upwelling phase of the Kelvin wave cycle. And then in February, March, massive westerly anomalies started pushing warm water, you can see here, off to the east. It made it to about a point south of California and then stalled and then reactivated, and now it's more aggressively moving off to the east, starting to erupt. But notice a good amount of warm water still hanging in the West Pacific. It hasn't completely shut down. The question is, will there be more? All right, so let's take a look at what's going on the surface. Here is Peru. Chile's down here. The blues are cooler water. So we see a little bit of upwelling here along the coast of Peru. Not unusual, pretty typical. But what we do see here, the yellows, oranges, reds, warm water. There's the Galapagos. We see it on the equator, moving off, filling the whole area from basically the Galapagos to a point. There's Hawaii, south of Hawaii, and then soon beyond there, and going down. So the main Nino 3.4 region area for monitoring El Nino starts at 120 west, goes out to 170 west, so off the chart here a little bit. 5 degrees north and south of the equator. Well, there's 5 degrees right there. You could say, yeah, that's all warmer than normal water. Going down here, the line's probably about 3 to 4 degrees south, so still a little bit of remnant cool water right here from La Nina. But this is steadily getting warmer, steadily falling south and dissipating. And if anything, it looks like some sort of a weak and not a Modoki El Nino. A Modoki El Nino would all be out here, but this warm water is erupting the whole way, south of, where's that, Nicaragua, that area, Costa Rica, that sort of thing. So, if there was no warm water here and it was all out here, we'd say maybe a Modoki type El Nino, which is kind of an El Nino, but not really an El Nino. But this almost looks like a normal positioned El Nino, but just not very strong at this moment. Kind of weak, but hey, it's, when is it? We're not even July yet, so not bad. Certainly better than La Nina, where this was all cold water a year ago. We're way past that, so we're at least neutral at this point in time. Oops, here we go. The 7-day trend. You can see pockets of warm water out here, even from about 115 west. That's just the 7-day trend. It's very noisy. A couple little pockets here of cooler water and warmer, sort of building off and on. So really only these couple of cool pockets here. So a generalized warming trend starting to set up on the equator. And then just stepping back, looking at the big picture, clearly warm water on the equator. This is where you need it. This is what affects the jet stream. Not so much up here. It's, believe it or not, it's really kind of in this area right in here. And it's doing that steady, slow warming trend. Certainly La Nina is gone. It's dead. It looks like a developing El Nino. Now the question is, you need basically 9 months of warming before one can officially declare an El Nino. So, if this started in about now, so let's say July, August, September, October, November, December, January, February, March. Yeah, about March we'd go, oh yeah, we're in El Nino, but probably by that time it'll already be falling apart. But still, it's better than La Nina, and what that means is that'll help support a stronger jet stream for maybe the end of summer for the southern hemi, but more so for the winter months in the North Pacific. The sea surface temperature trend in the Nino 1.2 region, so that's just the area around the Galapagos right off Peru, is kind of a noisy area, not necessarily indicative of anything. You can see it was way down here in April, steadily working its way up to maybe ½ degree below normal, kind of dipping off lately. So what is it today? Minus 0.834, so 3/4 of a degree below normal. But in the official El Nino monitoring region, temperatures as of today plus 0.185. So, 0.2 of a degree above normal right there. There we are. You can see, though, that look at the trend. In April, we were down 1 degree below normal, steady upward trend, neutral on June 10th, and trending slightly upward since then. The point being, this was La Nina, this is El Nino. All it takes is ½ degree below normal is, for a not long enough period of time, is La Nina. ½ degree above normal for a long enough period of time is El Nino, though preferably if you're going to run a real El Nino, you're talking 1 degree or 1.5 above normal. We're not there yet, but at least we're neutral, meaning La Nina is dead. And then finally, the forecast for the Nino 3.4 region, sea surface temperatures. This per the CFS model. You can see, well, here's about where we are. Maybe, supposedly, whatever, we're almost in July. Let's say 0.35 above normal. So, yeah, the model's overhyping it a little bit, but notice the trend. Steadily upward, up to 1 degree above normal as we get into October, up to 1.25 degree above normal as we get into November, and then slowly trailing off from there. But this would, if this plays out, you would have a modest to moderate El Nino. Nothing off the charts, but not unrespectable either. Certainly good enough to help goose up the jet stream and provide a above average winter for the North Pacific. And then looking at all the models, dynamic, so the CFS version 2 is right there. It's green buried somewhere in here. The dynamic models and the statistical, these are all the models across different meteorological organizations on the planet. And you can see they're all trending upward, suggesting, and this is like May, June, July, August, September, October. You get the idea. And the average of all the models, well, you can kind of look here and eyeball it. What's that? Maybe about 0.8 of a degree, maybe a little bit more. Or they've got it all listed out right here. June, July, August. So we'll just sort of roll down here. The neat thing is they just summarize it for you. Average all models, 0.8 of a degree, 0.9, 1 degree above normal on January. Okay? So that would get us a 1 degree above normal El Nino in the January time frame. Again, this is a forecast. It's not guaranteed to happen, but that would be good. That would put us in a much more favorable position for storm development in the North Pacific, therefore meaning improved odds for larger waves, a more frequency of them, and more storm days, that is more wind blowing on the ocean surface. So that means when you get a swell, it will last longer. It wouldn't just be a couple hour event or a 1 day event. Maybe you get a 2 or 3 day swell out of it. And then just let's go look at positioning of this forecast El Nino. And again, back to the CFS model, but you can see here, July, this is where they're predicting warm water. So this looks sort of like a Modoki El Nino sort of situation. But it's August. You can sort of look at the position and see it starting to build off, and there's the core of it right there. So pretty much almost south of California as we get into November, and then December building. So pretty much a not fully eastward El Nino, but certainly not Modoki, somewhere in between the two with the core of it, pretty much south of California. That, wherever the core of the warming is, that's where the core of the precipitation would be as well. So we'd say probably, or north of there. So relative to California, if all this plays out, maybe a normal to enhanced wet winter for California, and certainly good for storm development north of there, so in the northern Gulf over to the Dateline region, which is pretty typical El Nino sort of setup. So for right now, kind of a slack pattern, tiny, small southern hemi swell, pushing to the north, probably making it to California, Hawaii, somewhere in the late weekend time frame. Copious wind swell, though, to fill the gaps, so there will be something to ride. When the trades die, then the wind swell dies, and, then you have really nothing. So at least there's something to ride. The better news is the models are all starting to coalesce around some sort of concept of an El Nino this winter. Maybe not super strong, but not super weak either. Good for precipitation, good for storm development, maybe good for snow. So things are looking up. We just got to survive the next couple of weeks. We're guessing by about sometime in August, let's say mid-August, the southern hemi might start waking up a bit, and that would probably be about in line with the active phase of the MJO developing. And from there on, it's good news the rest of the way forward. So that's it for this forecast for tonight. We'll do it again next week, same time, same channel. Thanks for watching.